April 16th, 1986, 150 feet above the Libyan desert, Major Brian Shul gripped the controls of the fastest aircraft ever built as his threat warning system exploded with alarms. Multiple surface-to-air missiles had just launched, Mach 3 capable. Theoretically able to catch him, the radar scope showed them climbing, accelerating, hunting. His reconnaissance systems officer's voice cut through the cockpit. "Push it up." Shul jammed both throttles forward past their stops. The Mach meter climbed past 3.2, then 3.3. The aircraft was flying faster than its designers ever intended. The missiles were still coming, and they still had 12 minutes of mission photography to complete before they could turn for home. This is the story of the SR-71 Blackbird, the aircraft that flew so fast a lit match thrown into its fuel tank would be extinguished. The spy plane built from Soviet titanium to spy on the Soviets. The machine that leaked fuel on the ground by design stretched 11 inches longer during flight from heat and required pilots to breathe pure oxygen for 30 minutes before takeoff. This wasn't just another reconnaissance aircraft. This was engineering that defied physics itself. The Blackbird didn't look like other aircraft. 107 feet of midnight black titanium shaped like a stiletto knife, twin Pratt & Whitney J58 engines hung beneath a fuselage so hot during flight that mechanics couldn't touch it for 30 minutes after landing. The cockpit windows, made of quartz glass 1.25 inches thick, reached 620 degrees on the outside during cruise, hot enough that pilots wearing gloves couldn't touch the inside surface for more than seconds. Yet inside that inferno, air conditioning kept the crew at a comfortable 60 degrees while they flew at the edge of space. The engines were mechanical miracles. Each produced 32,500 pounds of thrust with afterburner engaged. But the revolutionary secret wasn't the engines themselves. At speeds above Mach 2, bypass valves opened automatically, routing compressed air around the engine core directly into the afterburner. The jet engine transformed into a ramjet. At cruise speed, the engines provided only 20% of total thrust. The inlet system provided the other 80%, gulping 100,000 cubic feet of air per second through carefully positioned shock waves managed by 26-inch movable spikes. The fuel system defied common sense. JP7 was a specialized kerosene so stable you literally could not light it with a match. Starting the engines required triethylborane, a chemical so reactive it ignites spontaneously on contact with air. Each engine carried just 16 shots of this starter fluid. Run out during a mission and you couldn't relight the afterburner. Game over. The fuel tanks leaked on the ground. This wasn't a flaw. It was brilliant engineering. The panels were manufactured to fit loosely at room temperature because designers knew thermal expansion during Mach 3 flight would seal them perfectly. The aircraft took off partially fueled, then immediately refueled in mid-air once the superheated panels expanded and sealed. No conventional sealing system could survive the 600-degree temperature cycles, so Lockheed's engineers simply accepted it. The entire fuselage was 93% titanium. Standard tools couldn't work the metal. Cadmium-plated equipment embrittled titanium on contact. Lockheed's Skunk Works had to invent entirely new fabrication techniques. And here's the Cold War irony. The titanium came from the Soviet Union. The CIA used shell companies and elaborate cover stories, including claims of building pizza ovens, to purchase rutile ore from the very nation this aircraft was designed to spy on. During flight, the Blackbird literally transformed. At Mach 3 cruise, skin temperatures exceeded 600 degrees Fahrenheit. The entire airframe expanded 3 to 4 inches as titanium panels grew with heat. Pilots heard the fuselage bang, crack, and pop during acceleration as the machine underwent its thermal metamorphosis. It sounded alive. From the cockpit at 85,000 feet, pilots saw the curvature of Earth. The sky above faded from blue to black. Stars appeared at noon. Visibility extended 350 miles in every direction. You weren't flying an airplane at that altitude. You were piloting a spacecraft that happened to need air to breathe. Brian Shul knew this machine better than most. He'd earned his seat the hard way. Shot down over Vietnam in 1973, catastrophic burns covering his body, 15 reconstructive surgeries over 1 year. Doctors said he'd never walk normally, let alone fly again. He proved them wrong, fought back to full flight status, then was selected for the SR-71. Only 85 pilots ever flew operational Blackbird missions, fewer than the number of astronauts. Shul was one of them. April 16, 1986. Operation El Dorado Canyon had just concluded President Reagan's retaliatory strike against Libyan terrorist camps following the Berlin disco bombing that killed American soldiers. Now came the critical follow-up, bomb damage assessment. Someone had to photograph Benghazi and Tripoli at Mach 3+ and 80,000 feet to determine if the strike had worked. That someone was Shul and his reconnaissance systems officer, Major Walter Watson. They launched from RAF Mildenhall in the United Kingdom. The mission profile was simple on paper: cross the Mediterranean, penetrate Libyan airspace, photograph both target cities, exit to international waters, refuel over Gibraltar, return home. But nothing was simple about Libya in April 1986. Gaddafi had declared a line of death across the Gulf of Sidra, claiming international waters as Libyan territory. Soviet-supplied surface-to-air missiles guarded every approach. SA-2 and SA-4 systems capable of Mach 3.5, theoretically fast enough to catch a Blackbird Shul, crossed the line at 2,125 miles per hour. Below, the desert stretched endlessly. Ahead, Benghazi appeared on radar. Watson's reconnaissance systems powered up, cameras ready to capture evidence of the strike's effectiveness. The photo run required steady flight, no evasive maneuvers, cameras pointed straight down. Maximum vulnerability. The first indication came from Watson's defensive systems panel. Lights illuminated in sequence, R for radar searching, M for tracking, L for launching. Watson's voice cut through the cockpit intercom. "We've got launches, multiple." Shul's hands tightened on the throttles. The SA-2 missiles climbing below them weren't training shots or warnings. These were kill shots. Soviet-designed, Libyan-operated with one mission: knock this American spy plane from the sky. But the Blackbird had one advantage: it could accelerate. At Mach 3.1, they were already faster than most fighters could ever fly. But with missiles tracking them, fast wasn't enough. Watson called again. "Push it up." Shul advanced both throttles forward, feeling the familiar resistance, then pushed harder, past normal cruise power, past the design limits printed in red on the throttle quadrant. The J-58 engines screamed as fuel and air mixed in the afterburners. The Mach meter climbed, 3.24, then 3.31. Shul's eyes were glued to temperature gauges. Now the aircraft was designed for Mach 3.2 sustained cruise. They were exceeding that. Heat built across the airframe. Leading edges glowed dull red. The windscreen temperature gauge climbed toward its limit. Too much heat and the quartz would crack. Too much speed and the engines could overtemp. But slow down and the missiles would reach them. Shul later described it. "My eyes are glued to temperature gauges now, as I know the jet will willingly go to speeds that can harm her." The Blackbird didn't have speed limiters. It trusted its pilot's judgment. And right now, judgment meant survival trumped caution. The Mach meter crested 3.45. They were flying faster than this aircraft had ever flown. The engines were functioning more as ramjets now, air compression alone providing thrust as fuel burned in the slipstream. Below and behind them, the SA-2 missiles climbed guidance radars, tracked them. Proximity fuses armed, but the missiles faced a physics problem. They'd been fired from stationary launchers. The Blackbird had already been traveling at Mach 3+ when the missiles launched. To catch a target moving that fast required perfect geometry. Any miscalculation, and they'd burn their fuel chasing empty sky. Watson's voice again. "Turn coming up." This was the most dangerous moment. They'd completed the Benghazi photography. Now came the turn toward Tripoli for the second target. Turns at Mach 3 required massive airspace. Bank too hard and structural limits would be exceeded. Bank too gentle and they'd stay in the threat zone too long. Shul began the turn, feeling the aircraft respond with that heavy, deliberate motion. The G-forces pressed them into their seats. Windscreen temperatures climbed higher. The missiles adjusted their tracks. But something had changed. The distance had opened too far. The missiles, designed for intercepting aircraft flying at Mach 2 or less, couldn't maintain their pursuit. Physics was absolute. Drag increased with the square of velocity. The missiles were burning fuel trying to catch a target flying faster than most of them could ever achieve. One by one, their rocket motors exhausted. They fell away, tumbling toward the desert below Shul, and Watson completed the turn. Tripoli ahead, more missile sites, more launches, more threats. But they knew something now. They knew the Blackbird could outrun what came for it. Watson's cameras captured every target, every bomb crater, every destroyed facility. The reconnaissance mission was succeeding, and below, Libyan air defense operators watched their radar screens as the American aircraft simply accelerated away from everything they launched. During one pass, their double sonic boom made Gaddafi scramble from a stage during a speech. Shul saw it later on television, the dictator who'd declared his line of death, diving for cover while the Blackbird's shockwaves rattled windows across Tripoli. The message was clear. You can fire, you can threaten, but you cannot touch us. Still at excessive speed, they turned south over Sicily. Shul finally pulled the throttles back to idle, but momentum at Mach 3.5 takes miles to dissipate. They overran their tanker over Gibraltar, had to orbit twice to bleed off enough speed for refueling. The tanker crew radioed congratulations. Word had spread through military channels. The Blackbird had done it again. This mission over Libya was one of thousands flown during 34 years of operational service. Blackbirds faced North Vietnamese SA-2s over Hanoi, Soviet SA-4s during Baltic missions, North Korean launches along the DMZ. Every hostile nation with Soviet-supplied air defense systems took their shot. The aircraft's success wasn't through luck. It was through titanium airframes and ramjet engines, through pilots who understood that the best defense wasn't stealth or jamming. The best defense was speed, pure, undeniable, physics-defying speed. On March 6, 1990, the final operational SR-71 mission set 4 speed records: Los Angeles to Washington, D.C. in 64 minutes and 20 seconds, West Coast to East Coast in 67 minutes, 54 seconds, Kansas City to D.C. in 25 minutes, 59 seconds. Every one of those records still stands today. 35 years later, no aircraft has beaten them. The SR-71 was retired not because it was obsolete. It was retired because it was expensive, because satellites offered alternative reconnaissance, because Cold War budgets couldn't sustain the operating costs. But nothing replaced it. The capability gap persists. The only aircraft ever to achieve that combination of speed, altitude and mission duration sits in museums. Now 20 aircraft survive in museums worldwide. The most famous rests at the Smithsonian's Udvar-Hazy Center in Virginia. Visitors stand beneath those black titanium wings and see an aircraft that still looks futuristic 6 decades after its first flight. Children ask if it's real. Adults ask if the stories are true. The speed, the missiles, they're all true. Every story. The Blackbird flew faster, higher, and longer than anything before or since it defied physics. The Blackbird, the untouchable, the machine that proved speed isn't just a specification. Speed is survival. Speed is victory. Speed is the difference between mission accomplished and another name on a memorial wall. And nothing, absolutely nothing, has ever been faster.